So today's lesson is 4.5 on immunity and vaccines with the essential question, how do we prevent ourselves from getting sick? So take a second, you can pause the screencast to copy down the lesson title and the essential question and start when you are ready. So just to recap what we've been learning so far in the last couple of days, we've been talking about pathogens, which are things like these, like viruses and bacteria. When they invade the body, our body knows how to respond and fight back. So the first thing that happens is our body recognizes that the virus carries a foreign antigen, which are these little shapes on top of the virus or bacteria. And the first thing our body does is the macrophage, which is one of our white blood cells, comes and engulfs or eats the virus. The macrophage then goes on to activate the helper T cells. The helper T cells activate cytotoxic T cells and B cells. The B cells produce memory cells and plasma cells, and finally the plasma cells make antibodies. And we've talked about what each of these things does, and so if you are confused, you can look back at your notes for what these different cells do. But anyway, here we have now an army of white blood cells and antibodies ready to fight against our virus. The problem is that this all takes a little bit of time, and during this time, that's when you start to feel sick. So you see this person is sick while their body is fighting against the virus. But eventually this does work. So this army will eventually get rid of the viruses in your body. That's why you start to feel better. When the viruses go away, you don't need this entire army anymore. So some parts of this army actually goes away as well once the virus is eliminated. But two things stay behind: your memory cells and your antibodies. And they actually stay in your body forever, and they protect you should the virus ever come back. And this is something we call immunity, or long-term protection from a pathogen. So you may have heard this word before, immunity, and what gives you immunity? It's the memory cells and the antibodies in your blood. So let's say that same virus comes back with the same antigen. Your memory cells and antibodies that were produced the first time will immediately recognize it, attack it, and trigger a faster immune response. And so this time around, you will not feel sick. Okay, so that is the concept of immunity. So this is the first check for understanding. I want you to write the answer on the worksheet or the screencast guide. So number one, define immunity. And then number two, which two parts of our body's immune response give us immunity against a pathogen? And you can choose A, B, C, D. Okay, so again, you can pause this screencast while you answer, but I'm going to move on. So we don't always want to get sick the first time, so the question is, how do we get immunity against a pathogen without actually getting sick? And you guys may know the answer. You go to the doctor sometimes for this shot, and we call that, of course, a vaccine. And one of the most famous vaccines is the flu vaccine, which also is called a flu shot. You see advertisements for it everywhere. And vaccines, they are important because they allow us to develop immunity against a pathogen without getting sick from it first. So to learn about vaccines, I want to show you the discovery of the first vaccine, and that is a vaccine against the disease known as smallpox. So you don't hear about smallpox very often anymore, but smallpox was not a friendly disease. So I just want to show you a picture of what it would be like to get smallpox. So this person has smallpox, and you can see it's a severe rash that starts around your face, but then spreads to many other places in your body. And so this is obviously not fun. And the worst part about it is, unlike chickenpox, which is mostly, it's annoying, but it doesn't kill a lot of people, smallpox killed 30% of the people who caught it. Okay, so that is, if let's say 10 of your friends caught smallpox, 3 of them would be killed from it. And smallpox was the first ever disease to have a vaccine, and instead of continuing to talk about it, I will show you this video about how they discovered the first smallpox vaccine. So just watch this.
In China, smallpox scabs were collected from victims and put into bottles. After a month or so, most of the smallpox viruses were dead or weakened. To make a person immune, the powdered scabs were blown into their nostrils. In India, the pus from a mild case of smallpox was used and smeared into a scratch on another person's arm. In Turkey, Lady Mary Wortley Montagu first witnessed the use of poxypus in 1717.
Using poxypus, how very interesting.
And was so impressed she brought the idea back to England. But the pus was sometimes strong enough to cause the full-blown disease and death. A way had to be found of infecting people without killing them. In 1796, Englishman Edward Jenner saw that milkmaids sometimes caught cowpox, and this made them immune to smallpox. Edward Jenner went on to prove that if you deliberately give someone a small dose of cowpox, they won't get deadly smallpox.
Okay, so again, what that video was showing is that if you deliberately gave someone disease cowpox, they would never ever catch the disease smallpox. And through this, they discovered the first vaccine that eventually wiped out the disease smallpox. So that's why today you probably don't hear about anyone with smallpox because it is no longer a naturally occurring disease. So what was happening here when they discovered the vaccine? Well, they actually figured out that rather than that, of course, a live virus triggers the immune response, right, like this, but it's really bad for you because it could actually make you sick or kill you. But what was in a vaccine is actually not the live virus, but a dead or weakened version of it. So they actually figured out later that cowpox and smallpox are kind of the same virus, but the cowpox is a weakened form. So vaccines today, they contain dead or weakened versions of pathogens. And so when you go to get the chickenpox vaccine, that is actually a dead or weakened chickenpox virus in that shot. When you go to get the flu vaccine, they have dead or weakened flu viruses in that shot. So why does this work exactly? It goes back to, of course, our friend the antigen. Even though these viruses are dead or weakened, they still have this antigen shape on top of it. And remember, that is what your immune system recognizes and fights. So check for understanding 2 before we move on. What is in a vaccine? So I want you to answer this on your screencast guide. Again, you can pause this while you answer it, but I'm going to continue. So again, going back to why does this work? When you are injected with the vaccine, that dead or weakened virus goes into your body. And even though it is dead or weakened, because it has that antigen, our immune system responds in the exact same way as if it were alive, right? So the macrophages, blah, 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 makes this army to fight this dead or weakened pathogen. So you don't get sick, but you do get immunity because the memory cells and the antibodies are produced. So again, vaccines give us immunity by triggering the immune response and causing our bodies to produce antibodies and memory cells. And of course, they stay in your body. So now if the live version of the virus comes back, and with that same antigen, they again trigger the faster immune response and prevent you from getting sick. Okay, so that is how vaccines work. So here is now your exit ticket. In order to enroll in most schools, students must be vaccinated against certain viral diseases such as mumps. So number 1, what is present in the mumps vaccine? Number 2, what does your immune system produce in response to the mumps vaccine that gives you immunity or long-term protection against the pathogen? And if you want, you can try this challenge. Explain why a student vaccinated against mumps can still be infected by the pathogens that cause other diseases, such as chickenpox.